Hi everyone, welcome back to the workshop, and it's repair time again, and this time I've got a matrix LCR meter, a bench LCR meter, the MCR-5200. Now I did actually acquire this LCR meter via matrix, and it's reported as having an issue. Now what I mean by that is it came back to Matrix via their Amazon return. So somebody had obviously bought it through Amazon, returned it for whatever reason, and it's got back to Matrix, and Matrix punt them out at a discounted rate. So I managed to get this one. Now when I bought this unit I had no idea what the fault was. It could have had a cracked screen, it could have had a fault, who knows. So let's power it up and let's take a look. Now the unit does actually boot up just fine, and I have actually been using it for the past few weeks and it's been working fairly well. Now I say fairly because it's not perfectly well. It does have an issue. Now if I plug in the leads, which came with the unit, all labelled nicely, and here we go. And if I connect a capacitor to it, I've got it already set up to show capacitance and ESR on 100 Hertz setting. If I just hook up a small capacitor here, and as you can see it's a 470 nanofarad capacitor and it's displaying perfectly well and showing an ESR of 6 ohms. I'll try a different capacitor. I've got a small electrolytic here. Let's try that. Almost 1000 microfarad. Well, yes, it is 1000 microfarad cap with an ESR of 0.15 ohms. So it is actually working fine. And I've tried the other modes and they work perfectly well as well. So what is the issue with this unit? Why was it returned? Well, if I just let the unit sit, whether I've got a capacitor connected or whether I've got the leads disconnected, if I just let the unit sit, you can see as it acquires a new reading, the digits will change obviously, but you'll get this little symbol here that will revolve as it's taking a new reading. And of course the keypad will actually respond perfectly well as well. But if you just let it sit like this, it might take 10 seconds, it might take 10 minutes, it could take half an hour, but eventually the unit will just freeze up. The LCD just completely freezes, none of the keypads, none of the buttons work, and the symbol will stop revolving. You'll be left with the capacitance at the last value, or on the odd occasion I've had the LCD go completely blank. So I'm just going to let it sit right now, and let's just see if I can get it to lock up. And there we go, it's locked up. Now it did take about 40 minutes to do that. Sometimes it'll do it not long after you power up. When it's cold it could take a couple of minutes, sometimes it'll take 10 minutes, and in this case it took 40 minutes. And I wasn't touching it at the time, it was just sat in the workbench like this. Now I've got a few ideas as to what possibly could be wrong with the unit. I have been inside it looking for dodgy connections in the wiring and etc, and no, I can't find anything. So I'm going to go back into the unit today. I have got some plans ahead to try and fix the unit. Now one other thing before we do go inside it, I did speak to Matrix back and forward about the problem. Despite me buying a returns unit, they were quite helpful in trying to get to the bottom of this problem. And the first thing I asked them for, can I get an updated firmware for the unit? And they sent me the updated firmware. And let me show you what happens when you try to update the firmware. So if I just reset it, power. Now when it does crash like that, none of the buttons respond. You have to turn it off and on again. And there's it working again. So I've got a stick here with a firmware file on it. There's a couple of different ways of getting to the firmware update screen, but even just by plugging in the USB stick, it will lock up the display. It locks the whole thing up. And I think that's the same type of crash as what happens randomly. And you unplug the stick and everything else is just locked up, as you can see. And the only way to fix it again is to reset the power. Now there is actually a procedure for updating the firmware, if I can remember how to do that. Update. So please insert disk. So you do that and it just locks up. You can't do anything. And as soon as it exits that screen there, as you saw, it just locks up again. So we'll try again. Okay, it's working again. About system, hit the update, asking me to insert the disk, so do that. Nothing happens. If I hit update again, nothing happens. And if I hit exit to come out of this mode, it just immediately locks up. Only place it doesn't lock up is whilst you're in that firmware update screen. Now I did talk to Matrix and they back and forward with them, and they told me to try a slightly different procedure to update the firmware, and none of it worked. Whatever I do, it just locks up. So let's open it up, let's take a look inside, and let's explore the ideas that I've got to possibly fix this crashing problem. Okay, so here we are inside the unit, and you can see you've got one large board at the bottom there. Rather nice, rather well made. The soldering's perfect, the layout looks pretty good. And of course over the left hand side here you've got the mains input IEC here, transformer here, and a small standalone board there, and that's just for cleaning up the incoming AC. You got a couple of common mode chokes, some X and Y class capacitors, etc. So you got the AC coming into the board on the bottom connector here, and this connector here with the 4 wires that goes back off to the selection switch, the AC selection switch on the back of the unit, and the secondary comes out here down onto the main board. Up here we've got a separate little board attached to the back panel. That's not a GPIB connector, it's called the handler interface, and it looks like you can connect this LCR meter to external equipment. They call it the sorting interface. I can only presume that's used in some sort of automation setup where you're automating the selection of capacitors and deciding which bins they go into, that kind of thing. So this interface here will just output there to the external machine. Get the power supply section underneath it. You can see the looks like a couple of regulators there, a couple of large capacitors, etc. Bridge rectifier, maybe another regulator down here, not too sure. And also over here we've got the logic for the actual interface to the front panel, BNC connectors there. And down here we've got the main processing section, and at the centre is an NXP LPC-2478F. That is a 208 pin microcontroller, and the reason it's got so many pins is because it can also interface directly to the LCD, which it does here. You can see the flat flex coming in, and obviously it'll interface directly onto the chip there. It can also address external RAM, and you've got a WinBond SD-RAM chip here, and down at the bottom there, that's the SPI interface flash memory, and that is where the user calibration etc will be stored, no doubt. Up here we've got a Max 2 CPLD, the crystal. Looks like we've got some sort of programming header there. I don't think that's for the microcontroller, though it could be. I think it's probably more for the Max 2 CPLD. Over here, this cable here is coming from the USB port on the front of the unit, and you've got an 8-pin IC down there. That's a power distribution switch for that USB interface, and you can see the supporting circuitry round about it. And I've got another 74 series chip over at the side there. Now, I was actually hoping I could possibly program the software, the firmware, directly to the main board without using the USB interface, perhaps via the programming header. But Matrix weren't too fast in coming forward and helping me out there with the pinout of this, etc. And I'd rather not go to the trouble of reverse engineering that. And like I said, it looks like it's for the CPLD anyway. Not too sure what this connector here and this missing footprints here are for. I haven't looked too closely at that. And you've got some more power supply stuff down here. I have resoldered some pins in that IC and some of the other packages round about this USB interface and also around the microcontroller, etc. And I'm not really finding anything to help me there. The unit's still got the same problem. So there's one thing I'd like to do first, and that is look at the power supply. I'm thinking because it's so random, it can crash within a couple of minutes of power up. It can last for an hour before it crashes. Really no rhyme nor reason. And I'm starting to think maybe it's the power supply. So I'm going to hook up my scope onto the 3.3 volt rail and any other rails that I can find and see if I can log any spikes, etc., or catch any spikes on the scope at the same time the unit crashes, and that might help me point towards a power supply problem. Failing that, I think what I am going to do is replace this RAM down here. I've had my fair share of electronics test gear with faulty RAM, and because the unit kind of crashes when you plug in the USB stick, I'm kind of thinking that there's possibly some bad RAM, bad addresses on that RAM there that are just not performing as it should do per what the software's asking it to do, sort of thing. So I've got another chip that I can replace that one with just in case. But first, the power supply. So let me go away and set that up. Okay, I've set up the scope. I've got a couple of wires off of the 3.3 volt rail and the 5 volt rail. I'm monitoring the 3.3 volt rail at the moment. I've got the scope set up to detect a fallen edge to trigger at about 3 volts. So it's currently sitting at 3.3 at the moment. Single shot should detect any dropouts on that 3.3 volt rail. So I'll leave it running until it crashes, and then we'll see if we've got anything on the scope. If I don't, then I'll set the trigger in above 3.3 just to see if we can capture any spikes on that 3.3 volt rail. Maybe that's what's crashing it. And failing that, I'll move to the 5 volt rail and do exactly the same. Okay, it's crashed. And look at the screen. Yep, I've only seen that a few times where when it actually crashes, it doesn't just freeze the display, it loses it entirely. It means the microcontroller's definitely stopping. And on the scope, no trigger, so it didn't dip below 3.3. So I'll set up the 3.6 volts and let's look for any spikes going up the way. And we've got a crash, but unfortunately the scope didn't trigger, so it didn't spike above 3.6 volts. So I'll do the same on the 5 volt rail and let's see if that's causing the problem. Barely started on the 5 volt test and it crashed, so they're coming in thick and fast now. So it didn't dip below 4.7 volts, is which I had it set up on the scope. So let me try 5.3, that'll be the last test on the supply rails. And there we go, we've got another crash, and this time we've got a nice white screen, no triggering. So I don't think there's any problem with the supply rails. Okay, so just to recap, I've pushed and prodded the board, wiggled components, connectors, reseated connectors, and it has no effect on the crashing. I've monitored the 3.3 volt rail and 5 volt rail to see if they spike low or high, and that's not the case. I've actually had the board out a few days ago and looked at the underside, and it's pretty clean, nothing to see there. So what I'm going to do now is I think I'm going to jump forward a little bit, and I'm actually going to remove the RAM. Always suspect from RAM ICs. I'm going to remove the RAM and I'm going to fit a new one because I've got some of them in my stock. And if that fails, then maybe I'll reflow the actual microcontroller itself and possibly even the CPLD. But let's remove the RAM IC first. Easy enough to remove that package and fit a new one. Now, as you can see, I've put a little metal plate there, and that's to guard the heat from melting the small electrolytic capacitor on the other side, which is pretty close to that RAM IC. So that should keep the heat well away. So let's get going and remove that chip. Next thing, clean up the pads. Okay, and let's fit the new chip. First of all, right, I'll solder it up, need to get my head right over it, and I'll come back. And there we go, quick bit of drag soldering there, and it's all looking perfect. So I'll just clean up the PCB now. Some IPA. And there we go, that's the chip all cleaned up. So I'll get my head right over it now. Just make sure there's no shorts or anything, any dodgy joints on that chip, and then we'll try for a power up. Okay, ready for a power up. Looking good so far. And yep, it's up and running again. Now I don't have the probes connected, but I'll just leave it running just like this. It usually crashes in this state, and we'll see what happens with that new chip fitted. Ah well, it wasn't the RAM, it's crashed. It took about 10 minutes this time, so yeah, we'll need to dig a bit deeper I think. I'll reset it. Now it could always be the firmware that's got an issue that's crashing, but I haven't seen any reports whatsoever online of other people complaining of crashes, much older videos, etc. Mine just seems to be the only one that's crashing, and that's why I'd still think it's a hardware problem, but you never know. So which direction I go now, I'm not really that sure. I could go and reflow that 208 pin package, the microcontroller there, maybe the CPLD as well, but when I press around the chip it doesn't seem to make it crash any more or any less. Just it's as if all the solder joints are perfect, so I'm not really sure what to do next. I have had the front panel off before. I've looked at the LCD, the ribbon cables down onto the main board, and there's been no problem there at all. Reseated everything. And on the other side, it's perfectly usable the way it is. Sometimes it crashes within 5 minutes, sometimes it'll run for half an hour, no problem. And it's not really a big issue just to switch the power off and on again and just carry on. So I'm in two minds whether to just leave it as it is now. I have been using it for the past month or so, with that circumstance, and it's been perfectly usable. A little bit inconvenient, but nothing really at all. So if you've got any suggestions, please comment down below and we'll maybe steer this repair in another direction. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel. Most of them are successful, unlike this one, and from the simple to the complex. Check them out, and thanks for watching.